1.7, writing proofs. This lesson is a little bit long, so bear with me. All right, first of all, you need to know what a proof looks like and how to justify and explain it. So here's the thing, with explaining what you're doing, it's what your thought process is that's automatic. So hopefully, as you're getting better at the proofs and justifying, it's just doing what you know you're supposed to do, but saying a reason with it. So it says, William solved an equation for x and wrote justification for each step of his solution. So I want you to look over here, and basically here's the equation, and it was given. So that equation is given. So after it's given, mathematically, what do you do with this? Well, I need to move this 6 and multiply it by 14 and multiply it by x. Most of you do that automatically and you put the little arrows. But what's the name of that? What makes you do that? That's the distributive property. So this side, the right side, is the justification side. So if you distributed or multiplied out the 6 times 14, you would have 84. And 6 times x would be 6x. All right, at this point, what do you do next to solve for x? So hopefully you know, I got to get this 84 over there with the 108. Well, mathematically, what do you do? So I'm going to pull this down. You subtract. Use the subtraction property of equality. Now, it doesn't show it here, but you should have minus 84 here and minus 84 here underneath the 108. So it's just showing the 6x equals 108 minus 84. You're subtracting. Okay, and when you're just like cleaning it up and making it more simplified, you just say that. It's simplification. You are simplifying. Some teachers don't require this middle step of showing work. You could just go from this second step all the way down to the simplified version and say subtraction property of equality. And you would be implying that you subtracted 84 on both sides. All right, so we're getting close. We're in the home stretch. How do you get 6 by itself? When 6 or any number is touching a variable, that means it's multiplied. So you have to undo that multiplication by dividing. So just like subtracting on both sides, it's the same idea. And it's dividing on both sides. You could say division property of equality. It looks like they used multiplication property, so they must have multiplied by the reciprocal or multiplied by 1 over 6, which is exactly the same thing mathematically as dividing by 6. So as a teacher, I would have accepted division property of equality, assuming that you divided by 6. All right. So yes, there are more than one way. There are more than one ways to write a proof, and different rules that you can use. Mathematically, it still gets you to that end result. Vertical angles are very common. They show up in geometry all the time. So the vertical angles basically are congruent. Well, not basically, they are. They will always be congruent. They are across the vertex from each other. This right here, this point, the intersection point where lines cross, that's the vertex. And angles across each other, so 1 and 2, those are called vertical angles, and they're congruent. They're going to be the same. 3 and 4 are across the vertex from each other. They will also be the same. So as you manipulate here, do you see how it's 60 and 120? No matter what you do, opposite angles, those vertical angles across from each other, they're still going to be the same no matter how I move it. See how they're always the same? You can move this one. So vertical angles are always congruent or always the same measure. We need to write a 2-column proof. Now we're going to start out a little bit basic. So you start with a theorem. A theorem is a conjecture that is proven. So it's a hypothesis. You think this is the rule, but they are actually proven. So a theorem is a proven rule. So you're going to prove vertical angles. The vertical angle theorem. You cannot use a rule to help you prove that rule. So I'm trying to prove that angles 1 and 2 are congruent. Well, I just told you they are congruent by the vertical angles rule or vertical angles theorem, but I can't use that in the proof. So I'm going to walk through this solution with you, and I'm hoping it makes sense. So it's a convincing argument. That's what we're doing. So first of all, we're going to write what's given. So most proofs have a given information somewhere in the problem or the visual. So I'm going to slide this down. And do you see how angles 1 and 2 are vertical angles? That is a given. And I'm going to keep going. What else do you notice? Look at the visual, and after any given, look at the visual and say, okay, well, what else do I know? Well, I do know that angles 1 and 3 together make this straight line. Do you see that? And then 3 and 2 make another straight line over here. So I'm going to see if that's what they did. I don't know. Yep, it says 1 plus 3, the measure of angle 1 plus 3 equals 180, because they make that straight line. You could have said the rule was they're a linear pair. You could have said they're supplementary angles. In this case, they're both the same. They both mean the same thing. They add up to 180. Okay, and if you scroll down a little bit more, it's exactly what I said. 1 and 3 make 180. 3 and 2 make 180. So those two sets equal 180. Now, if you have two things and they're equal to 180 or equal to the same thing, they should probably be equal to each other. So let's see what they do next. Transitive property. Transitive property is exactly what I just said. And when I teach this live, this is what I say. If this equals 180 and this over here equals 180, wouldn't these two things equal each other? So that is the transitive property. It's not exactly substitution, but it kind of is. You're taking something equal to 180 in this case, something else equal to 180, and if they're equal to each other, or they're equal to the same thing, they're equal to each other. So it's kind of like you miss out on this middleman right here. So just set them equal. That's called the transitive property. So angles 1 and 3 should equal 2 and 3. So 1 and 3 together should equal the same thing as 2 and 3 together, which is 180. Okay, keep going. Oops, I want to still keep that picture. Now, if they both equal 180, do you see how on both sides of the equation they have that measurement of angle 3? That little m means measurement. So angle 3 is on both sides of the equation. But if you have the same thing on both sides of the equation, get rid of it. So you can subtract it. You can subtract this measurement of angle 3 here, it would cancel. Subtract measurement of angle 3 here, it would cancel. And you'd be left with measurement of angle 1 equals measurement of angle 2 because you're subtracting. You're subtracting the same thing on both sides. That's exactly what we're trying to prove. So I'm just going to slide this down. And it says the measurements are equal. Well, equal means that the actual angles are congruent. So all of this, these are numbers. This is actual values or measurements. That's when you use the equal sign. If you're talking about a figure or an angle or like a hexagon or like a shape, then you would use congruent. So congruent and equal are used at different times. Equal, all these are equal because they're dealing with numbers, measurements. But you use the congruent when you're talking about angles. And that's what we're doing. We're proving. So step 4, we were so close. We're there. We totally did it. Exactly what they're asking. But we just need to convert it to congruent opposed to equal. So I go here and say, well, the definition of congruent means that the measures are equal. So even if I didn't know definition of congruent angles as the rule, I could explain that rule saying if the measures are equal, then the angles would be congruent. And I could write that here, right here on step 5. Okay. And there's good information here on the common errors. I'm going to go back to this one. Now you're going to write a common proof or 2-column proof. When you write a proof, most teachers require you to have something. If you leave it blank, automatic 0, you just failed it. Okay, so you better have the first statement and the first reason. And I'm hoping you know where to find those. Let's see. Did you say the given? I hope so. So if you put the statement here, ray BD bisects angle CBE, put that here and write the word given, you're already going to get some points and you literally just copied. So if you can copy the given and put the word given here, fabulous. And then as you type, you can get more spaces, but you could put this information, what you're trying to prove, if I can highlight this, it won't let me, but this kind of what you're trying to prove, you could put at the very bottom. So angle ABD is congruent to angle FBD, but you want to add rows as you go. So I'm just going to add a couple rows in there, just throw it in. You can always delete them after. And I would put down here at the very bottom on the statement side, what you're trying to prove. Never use the word proof or prove as a rule. Proof is not a rule. You cannot use that. So you'd have to get there in other ways, other rules that you have learned. But make sure you're starting statements and the reasons, start with the given and end with what you're trying to prove. At least that will get you some points, and then try to figure out the steps in the middle on the way. Okay, applying the vertical angle theorem. So to apply the vertical angle, look for vertical angles. So it says, the diagram shows how glass lenses change the direction of light rays passing through a telescope. And I'm sure you've seen a picture like this in science or another class in math or whatever. So you see these all the time, maybe even in photography or art. What is the value of x? So find x, looks like it's right over here. Look for those vertical angles, especially since it tells you at the top we're dealing with vertical angles. So it's saying this angle right here is x. Well, vertical angles are across the vertex from each other. So if this side is x, I need to find whatever this side is. So here's x right here. I'm going to go over here. Well, this whole thing over here is the other side of the vertical angle. So if this part's 11 and that's part's 11, try to figure out what x should be. The solution is under here. I'm not going to say it, but I'm hoping you can see that this total, that's a hint, and this should be the same. All right, here's one that has algebra involved. I would do this in a step-by-step mathematical way. You could do this in your notebook, or you can do this on the computer. But bottom line is, these two things, right here and here, are vertical angles. So I'm going to say 6x minus 45 equals, what does that say, 4x plus 5? Okay, there's my equation. Why did I set them equal to each other? If you can answer that, awesome. Here's the reason. These are vertical angles. The angles are congruent, which means the measures are the same or equal. So set them equal. If you know two things are the same, the vertical angles will be the same. Set them equal to each other. So I did. 6x minus 45 equals the other side, the other vertical angle, 4x plus 5. And then you solve. So in this case, it doesn't ask you to write a proof. It doesn't ask you to give your reason step by step. I'm just going to show my work like a regular algebra problem. So I'm going to, let's see what I'm going to do. I'm going to subtract 4x on both sides. We go over here, minus 4x. Okay, so I'm subtracting 4x on both sides. I would be left with 2x minus 45 equals 5. Okay, I still need to get the x's by themselves, so I'm going to move that 45. So I'm going to add 45 on both sides. And if you do that, if you're adding 45 to both sides, then you would have 2x equals, let's see, 50. I hope you know what to do. Getting closer. So get that get the x by itself, so you have to get rid of the 2. So you're going to divide by 2. Oh, I didn't even know I could do that. Fractions. Nice. Divide by 2. Let's see if it will work on here. It does. Divide by 2. It looks kind of weird, and it messed it up a little bit, but that's all I can do. So I'm going to divide by 2 on both sides. It messed up the formatting, but that's okay. Now I can't get out. Okay, so I have x equals 25. And then that would be my result. If it says, let's say, it says find the value of x, period, then I would be done. X equals 25. But it says find the value of x and the measure of each labeled angle. So I'm going to take that 25 and plug it in here. 6 times 25 minus 45. I would get my result. And then I would say 4 times 25 plus 5. And I better get the same result as I did on the other side of the angle, or you know you did something wrong, because they have to be congruent. All right, here's one. I'm not helping you at all with that one. I'm hoping you know these are vertical angles. Okay, here's another one. I love these. This is actually kind of like a substitution or a transitive property. So think of it as that. It says congruent supplements. First of all, you have to know what supplementary angles are. Supplementary angles mean they add up to 180. So if you have 2 or 3 or 10 angles that add up to 180, those are called supplementary angles. They might be on a straight line all at one point, or they could just be floating like this example, like floating angles out there somewhere. So it says 1 plus 2, measurement of angle 1 and 2 are 180 degrees. Okay, so those are considered supplementary angles. But then it says 3 and 2 add up to 180. So 1 and 2, those are supplementary. 3 and 2 are supplementary. So think of it as kind of if these both equal 180, 1 plus 2 equals 180, 3 plus 2 equals 180, shouldn't these equal each other? That's the transitive property. So if I had that, I could think of addition, and I would set up just like we did the vertical angles theorem. But if they together equal 180 and these together equal 180, wouldn't angle 1 and 3 be the same? That's what this theorem is telling us. That if they are congruent, if two angles create supplementary angles with the same angle or congruent angle, then they will be congruent themselves. Okay, there's another rule just like that, but it's complementary. So complementary are very similar to supplementary. Complementary equals 90 degrees. So when you're learning these, those words are kind of weird. So complementary is 90, supplementary is 180, and this is a stupid way to remember, but hopefully it helps. C, complementary, C comes before S, right? Supplementary. C is earlier in the alphabet. 90 is earlier or a lower number. Supplementary, if I go back, S is further on in the alphabet, and 180 is further on down the number line, or it's a bigger number. So they're actually kind of in order. So complementary is the smaller number, supplementary is the larger number, the 180. Okay, same thing, 1 and 2, if those add up to 90, and 3 and 2 add up to 90, then the two angles that create that, they would be the same or congruent angles. Okay, writing in paragraph proof. Paragraph proofs we don't do as often as two-column proofs, but you should try this. I want you to try this. Try that 1 and 2 are supplementary. Think, okay, well, what does that mean? How do I say that? And a paragraph proof is just like a two-column proof, except it's written in a paragraph form. So if you look at this, oh yeah, here's the proof. It's just written out all in sentences. Okay, so you can look at that and see if you can figure that one out. Okay, same thing, write a paragraph proof. If you feel more comfortable and if your teacher allows you, maybe ask them, can I write a two-column proof instead of a paragraph proof? See if that's okay, because the information is the same. All right, theorem 1-4. This theorem says all right angles are congruent, which logically I hope makes sense. Angle A is 90 degrees. Angle B is 90 degrees. So if A equals 90 and B equals 90, shouldn't they equal each other by the transitive property? Yeah, so they do. So all angles, all right angles are going to be congruent. They're going to be 90 degrees. Theorem 1.5 or 1-5. So it says, and these don't have names, they're just called theorems. So you would have to explain them on a proof. If two angles are congruent and supplementary, then each is a right angle. So what it's saying is these two angles 1 and 2 together equal 180, but they're the same angle. So let's just use a straight line. If there's a straight line and there's two angles on here that are identical, well, that would have to be like straight up like this. Here's the line. Here's the angles right here and right here. So those would have to be 90 because it's basically dividing 180 in half. So if you took 180 divided by 2, because they're going to be the same measurements, angles 1 and 2 are the same measurements, then they would each be 90. So they are right angles. Linear pair theorem. The sum of the measures of a linear pair. I'm hoping you can see the word line right here. Oops. Line or linear, that means they make a line. So there's 180 degrees in a line. So if you have two angles, a pair of angles that make a straight line, they would be 180. So look at this manipulative. No matter what I do, if you add those two numbers up, they equal 180. Equal 180. Whoops. Still equal 180. So if I move this, it's still a straight line, but just at a different angle. Those numbers still equal 180. Let's just try to make the 90, the theorem that we just talked about. Let's try to make this exactly 90 degrees if I can. There you go. Look, 90 and 90. They're two identical angles and they equal 180. So you can manipulate this and mess with it and try to discover new things. All right, so writing a proof using a theorem. We just talked about all these rules, so now what? So what you're going to do is you're going to write a two-column proof. Now to show you this, I just want you to see it so you remember what it looks like. I'm going to hit the solution, and notice it's a two-column proof. Where do you start every proof? The given. So go look at the given. I'm going to start with exactly what it says right here, the given, and I'm going to see if that's what they started with. They didn't. Oh no, what do I do? But look closer. They did. Measurement of angle 1 equals measurement of angle 2. They wrote it in step 1. They wrote the next part in step 2. So sometimes the given doesn't look exactly how it's written, but it is. It's the exact information, just they might have broken it up. Okay, I don't want to show you the rest of the proof, but you can look at it on your textbook if you would like. You are trying to prove that measurement of angle 3 equals 75. Again, write a proof. This one you're going to do on your own using some of those rules we just talked about in this lesson. And then this last part, we're getting close to the end when it says the summary. It says proofs. Use given information and logical steps to justify using basically all the rules, definitions, postulates, theorems, and properties. So this side has all the reasons or rules. This side has all the math. This is a 2-column proof. This exact same information, it's just a paragraph proof. So give this your best shot. I hope you do great, and good luck.